And for the second part of proving triangles similar, we're going to do this little worksheet called Are We Similar? And I'm going to show you a couple just to go over it with you, like actually one or two of them. I'm going to have you do a couple and then check your answers with mine, and then I'll show you some of the confusing ones. So if you want to get a head start, you should do numbers 1, 2, 3, and then 7 and 8. I'd like you to wait a second on 4, 5, and 6. I'm going to go over number 1 kind of slowly, and then I'm going to ask that you pause it just in case you don't want to hear me talk while you're trying. But you should be trying these on your own and not just watching me do them all and then watch mine in hindsight. All right. So for this first one, we need to decide between the following options: side, angle, side similarity, side, side, side similarity, or angle, angle similarity. It's going to be one of those three options or nothing. So when we look at them, we have one angle given to us here and two sides. So the only option we have is to try for side, angle, side. So I'm going to color the sides: the smaller side of the smallest triangle with the smallest side of the big triangle. And then the next side of the small one with the next side of the big one. And we're going to set up a ratio to check and see if those sides are proportional, because if they are proportional, then the triangles are congruent. So 3/9 corresponding parts go together, and then 5/15. Since we did the small triangle over the big triangle first, we need to do the small triangle over the big triangle second. All right, and then we're going to check and see if these are proportional. This equals 0.3 repeating, and this equals 0.3 repeating. Since these are the same, then yes, these triangles are congruent by side, angle, side similarity. Okay, I'm going to recommend that you pause the video now. I'm going to slowly and quietly go through number 2, 8, or 2, 3, 7, and 8. So as you finish a problem, feel free to check it and then go on, or do all 5 or 4 and then go back and check them. But meet me back in a few minutes because I need to talk to you about some of the weird ones. All right, here I go. All right, hopefully you checked your answers with mine. Keep in mind that something like this one, I could have done, and you can watch in my calculator over here, I could have had 39 over 63 for the first one, 52 over 84 for the other one. And you can see that even though the numbers are different from these, they're still the same because we kept them corresponding. This one we did with the big triangle on top and the small one on the bottom across. The other way in the calculator right now has the smaller one on top and the bigger one on the bottom. All right, we're going to go over number 4 and then number 5, and then you're going to do number 6. For number 4, we have 2 triangles. Just want to remind you about this kind. We have this triangle here, the little one, and then the pink one, the big one. Okay, and we actually have a couple choices. We could either try this by side angle side, using this angle right here as our middle angle, or side, side, side. I'll do it by side angle side since I just marked that angle, but I may take a minute and do it the other way also. All right, so for this one, we have this side. Well, we know we're going to need 2, right? So we have 15 as the short side of, or one of the sides of the smaller triangle, and the corresponding side would be this whole way across, basically segment RP. How long is segment RP? Right. Okay, just add those together. So 15 over 20. And the other side, we have 18 for the small one over the whole thing, QP, which would be 6 plus 18, which is 24. All right, we're going to check to see if those are proportional. 15 over 20 is 0.75, and 18 over 24 is 0.75. Since these are the same, then yes, these are similar by side angle side similarity. All right. If by any chance we decided to go with side, 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 we would have also had a fraction 12 divided by 16. And again, you can see that's the same. If you did it that way, instead of using the angle, it would be side, side, side similarity. And that's fine. All right. And number 6. In number 6, we have these arrows. And hopefully you remember that those arrows are talking about parallel lines. Parallel lines don't tell us that things are, or sides are congruent, but they can help us with angles. Right here, you can see that this angle here and this angle here, those are corresponding angles. Remember? They're angles in the same position when 2 parallel lines are cut by a transversal. Okay? And then we have another set of parallel lines. This one and this one with the same transversal. And that creates 2 more corresponding angles, just like that. Hopefully that makes sense. If not, watch that really slowly. This is a very popular kind of a problem. Now we have 2 pairs of corresponding angles in the triangles. So yes, these are congruent by angle-angle similarity. All right, I want you to try number 6. Pause the video now and then go back and check to see if you did it right. Okay, go.